Here's what's coming today on the Woodworking Network podcast.
A heavy piece of wood could be a light piece of wood. It can be perforated in ways that aren't simply drilled through, but in complex ways that are much more three-dimensional. So the kinds of products that could be produced, I think, are yet to be discovered.
Welcome to this episode of the Woodworking Network podcast. Join us as we explore the business of woodworking, big and small, and what it takes to succeed. I'm Will Sampson. Today's episode is sponsored by the Executive Briefing Conference. We'll be talking with Ronald Rael, Professor of Architecture at UC Berkeley College of Environmental Design and co-inventor of Forust, a new 3D printing wood product from a company called Desktop Metal. But first, I want to talk about, are you ready for additive manufacturing? I've been woodworking since I was about 6 years old, and all that time there has been one constant. You start with big pieces and you make them smaller until you're done. In the extreme, you start with a tree and make it into boards, then cut those boards into parts to make furniture or whatever. At the end, you have your finished product and a pile of sawdust and chips that are waste. Using a technical term, that process is called subtractive manufacturing because everything you do takes something away from the previous piece of material you were working with. The only exception is when you start combining parts you've made by subtractive processes to make something bigger. But now there's a new kind of manufacturing that starts building things up from the beginning and creates no waste. In fact, it typically uses waste from other processes. This new kind of production is called additive manufacturing, and it's the basis behind 3D printing. In its most popular forms, 3D printing typically squirts out molten plastic in layers to build up a finished part. It's not unlike the process that goes on inside an inkjet printer, where dots of ink are sprayed onto the paper with each pass of the printer head until an image or type is created. But there are other forms of 3D printing that have been around for a while too. In metalworking, there is a process called direct metal laser sintering, or DMLS. They use lasers to bond metal powder to build up complex parts precisely. A similar process is now being applied to woodworking, using lignin and adhesives to bond wood dust and create solid wood parts from sawdust. What additive manufacturing does is it forces you to think differently. It also opens the door to making parts and products that would have been impossible to make with conventional subtractive processes. Parts with complex internal structures can be made as one-piece part without joining and assembly. That eliminates processes and waste and could make for stronger, lighter wood parts. After decades of subtractive woodworking, my head naturally solves woodworking problems in a subtractive manner. How big of a piece of lumber do I need to make this part? What do I need to saw, drill, route, shave, plane, joint, or stand to get to my finished part? Be sure to figure my waste into the calculations too. But with additive manufacturing, the focus is all on the part design and the 3D printing device that will make it. No additional tooling required, no waste. I'm not sure my subtractive woodworking brain is ready for that, but it's an exciting opportunity. Before we get to our interview with Ronald Rael, let's pause for a word from our sponsor. EBC is a superior opportunity to learn, be inspired, and have face-to-face interchanges with top leaders in the woodworking industry. The 2021 EBC will be held September 8th through 10th at the spectacular Broadmoor in Colorado Springs. In addition to top speakers and presentations, there will be tours of Concepts in Millwork and the Mill Woodworking Training Facility. It's an unparalleled opportunity to obtain business intelligence to improve your enterprise while networking with the industry's brightest stars. You can learn more at executivebriefingconference.com. Now let's learn more about the brave new world of additive manufacturing in wood.
Today, I'm pleased to have as my guest Ronald Rael, professor of architecture at UC Berkeley College of Environmental Design and co-inventor of Forust, a new 3D printing wood product from a company called Desktop Metal. Welcome to the Woodworking Network podcast, Ronald.
Thank you, Will. I'm happy to be here.
First off, I think a lot of our audience has the impression of 3D printing as something that squirts out little plastic items and has little to do with woodworking and wood products. You're the co-inventor of a new wood-based 3D printing product called Forust. Can you explain what exactly Forust is? And I should say Forust is spelled F-O-R-U-S-T. So it's a little different than the woods. So what is
Well, Forust, I'll talk about the name for a second. We decided to go with Forust with US because we believed that maybe we could preserve the forest for us, the planet, and for the future. And so that's the reason for the different spelling. Because what we do that's very different from other forms of additive manufacturing is that, yeah, maybe many of your audience members have heard of 3D printing and think about plastic squirted through a little nozzle. And sometimes there's an introduction of different kinds of materials like metals or woods with that plastic. But our process is very, very different. We use recycled and upcycled sawdust. So we're taking the sawdust powder and we're spraying it with a biodegradable and non-toxic adhesive to stick it together. So we're reconstituting sawdust to create larger wood products.
That's interesting. So what kinds of things could Forust be used for?
Well, it could be used for almost anything. I mean, it's really up to a designer's imagination, but we can imagine things like architectural products. So for interiors, any kind of wall cladding, surfacing, almost anything you can imagine, luxury interiors, consumer goods, furniture. So really we're starting from the particle of sawdust, and we're able to imagine if you grow those particles of sawdust and adhere them together to make any shape, you can really make anything that you might imagine. And what's very special about the additive manufacturing process is that because we're not subtracting, so most woodworking is subtraction, right? You start with a forest and a tree and timber and lumber, and you carve it or you saw it or you mill into it. Because we're growing it additively, we can make shapes and forms that could not be made possible with other forms of tooling. And so that opens it up to new kinds of possibilities, maybe even products that are yet to be imagined.
That was definitely a question I was going to ask you about, because our audience is totally adapted to the subtractive manufacturing model. So what does it take to get them and their engineers and their designers to think additively and to be able to solve problems with an additive process instead of a subtractive process?
Oh, that's interesting. I think that woodworkers or craftsmen begin to think based on the tool. They might think in terms of what does a chisel do, or what does a bandsaw do, or what does a CNC mill do? And craftspeople begin to think through those tools. And I think one thing that we have to recognize is that this is a very new kind of tool. And that's simply what it is. And the tool allows us to produce new kinds of objects. So familiarizing oneself with the tool, but also recognizing that, well, I think in a certain way, one has to abandon first this conception of what it means to subtract from wood and just allow oneself to imagine what might be possible. So, for example, if you wanted to make a very large sphere or void inside of a block of wood with a very small hole coming into it, I can't imagine a tool that would do that very easily, or if at all, but that could be absolutely possible with additive manufacturing. And so allowing oneself to just challenge what one thinks of the tools that are available today and thinking about this as a new tool is one way to get on board. And because so much of design today happens through 3D design using CAD software or 3D modeling software, that those kinds of tools as well, those digital tools, are very much compatible with the additive manufacturing tools that we use.
Now, getting back to the material itself, how strong is this material? What are the properties of it?
Well, it's an isotropic material, and it has strength similar to, or if not greater in some cases, than wood. And so we can make it very strong. It has structural capabilities. Our print sizes are limited to the size of the machine. So whereas you might be able to buy a piece of wood that's as long as a semi-bed, our ability to produce objects are limited to certain machines that we have at our disposal. And we have smaller machines and larger machines. But the beauty of it is that most wood products, if they're assembled, are made of smaller wood parts. And so we can manufacture many parts to produce larger structural items. And I don't want to exactly say that it's like laminated timber, but in a way it's laminated at the microscopic level. But then we can also laminate parts, but those parts don't have to be flat like laminated wood products. They can be many different shapes, and they can be joined together and connected and glued.
Yeah, so you could have very complex joinery,
Right.
Additive process to put parts together. Now, natural wood expands and contracts over time in relation to moisture content. Does Forust do that, or is it more dimensionally stable than wood products?
Well, like engineered wood products, it does have a greater dimensional stability. And like every wood product that you might find in one's home, or it's often treated with some kind of coating to protect it and preserve it. So that helps that as well. And we use biodegradable and non-toxic and sustainable coatings for our wood products. So that also helps with the stability and the strength. But what's interesting about that is that it's infused into the layers. So it's not just an exterior surface coating, it's actually infused several layers in. So rather than being sprayed on or painted, as you might find on a piece of furniture or table, this is embedded much more deeply within the wood particles.
So you can actually have a more or less pre-finished part when it's finished and comes out of the 3D printer. Is that what you're saying?
Well, we do what's called a post-processing. So there is some
okay.
finishing afterwards, but it has the ability to exist within the layers, the network of layers within the additive manufactured part.
Now, I saw something saying that Forust can actually be 3D printed to show grain structures. Is that just cosmetic, or does the grain actually add strength to it as it does in a natural wood product?
Well, there's a couple ways to answer that question. I mean, because additive manufacturing is layer by layer, in the same way trees build up layers as they grow, there is a certain directionality to the material. And so those layers, in some cases, can emulate or appear to be like wood grain, as if the product actually grew, just like in the same way a tree grew. But we can do some very special things layer per layer as well, like we can introduce different colors into the layers. And so because it's printing, and additive manufacturing is called 3D printing, we can not only print the wood particles, but we can also print images onto or even into the wood. And so if you wanted to emulate a wood grain of any kind, you actually could do that within the wood structure, and it would be, as you say, cosmetic. But I want to take it a little bit further than that, because it might be seen as a much more refined way of finishing a wood product as well, because we're applying a very hyper localized color to each layer. And so imagine if you were using a particular stain, but you could take that stain with a fine paintbrush and you can paint it through the layers or within the layers itself. So that's pretty exciting, because what we've been doing so far is emulating different kinds of wood grains, but it could be actually anything or any image. And so that opens it up to new kinds of possibilities of what applying finishing to a wood product might look like. And that's yet to be discovered. Yeah.
Yeah. No, I think, in my mind, I just keep thinking new possibilities that could come with all of this. Like one of the things that occurred to me while we were talking is that, if somebody was repairing, an old house or an old piece of furniture that had, unique moldings on it, that it would be a heck of a lot easier to make a replacement part by 3D printing it, because you could just draw the molding profile in CAD. You wouldn't have to cut molding knives and all of that and run a length of molding to justify it. You could make exactly the right size part that you needed, exactly the right profile, just doing it on the computer and then 3D printing it.
That's exactly right. And that's one area that we're really interested in. In a historic renovation, for example, you might have a particular molding and it might be rotted. And so there might be a very small section of it or something. And so you'd have to go through all this custom tooling to replicate it. And that could be very expensive. But today you could actually take a 3D scan with your telephone, with your iPhone, your smartphone, and you will have an instant CAD file that you can deliver it to us, and it's ready to print, which is really incredible.
That's great. So that sort of begs my next question. It sounds like, now, what kind of equipment and training investment does it take to get started? It sounds like you're going to be having a sort of a service, or have vendors that can provide the service so that somebody can outsource this process and doesn't have to necessarily own it. Although some might want to own it once they get going.
Yeah, well, right now we're working as a service bureau, and so people can send us files, and we will make them for customers. So we'll see how we grow over the coming years, but the technology is a really interesting technology, and it's one of the oldest forms of 3D printing. It's been around over 30 years, and it's something that just hasn't used many different kinds of material technologies. And so one of our innovations is that we've been able to introduce a new type of material to the system. So even though it sounds very futuristic and very novel, and it's also a technology that's been around for quite some time, but hasn't been used in this particular way. And so it'll be really interesting to see how we introduce this to the larger woodworking culture and how it's adopted by that culture. And I think it's going to be very exciting to see how that takes shape.
I think that's going to depend a lot on what we were talking about earlier on subtractive versus additive manufacturing and the thinking that goes with that. I know that a lot of woodworkers definitely will have to do a mind adjustment when they're thinking about doing an additive process. But now with CNC manufacturing adopted so completely through the woodworking industry, I don't think that the technology or the computer side of things is as daunting as it was once upon a time for woodworkers. But it's just the physical thinking of, I'm not going to remove material to get the part I want. I'm going to create this thing out of dust.
Yeah, I think you're right. I think there has to be sort of a culture shift a little bit, and a mind shift around thinking about what's possible. But what we want to do is we also want to make software tool sets available to customers, and so that they can work through additive design processes. In other words, that I think what has been more accustomed to by customers or craftspeople in the woodworking world is that we've worked through drawings, and drawings are very 2D. And so a CNC machine, for example, will take 2D drawings and cut them out of flat stock material. And so how do we develop a tool that allows those same craftspeople to think through something in 3 dimensions rather than 2 dimensions? And that's going to be a really amazing moment, I think, thinking through how one designs or creates a product in wood.
Well, a lot of wood manufacturers these days are using 3D modeling. They got into it in some respects as a sales tool because it made it easier to visualize things for customers who weren't used to looking at 2D drawings. But they are using it from relatively simplistic forms like SketchUp on up to most of the tailor-made design programs for woodworking all have 3D modeling built into it.
Mm-hmm. That's
So
right.
it's that part of the process I don't think is as daunting as just thinking of additive manufacturing as a solution for some challenge that they're facing in manufacturing. Or the next step would be to think of additive manufacturing to create a whole new product.
Right.
The things like we were talking about as far as restoration work, repair, that probably is a foot in the door to convince some folks. But I think where you really get a full adoptance is when people start thinking about, oh, I could make this product that I always wanted to make that I never could possibly make or couldn't make, profitably and easily with an additive process.
Right. And I think that has to do with there's lots of ways to think about efficiencies in that way of making, and either the efficiency of the product that they're producing or the efficiency of the process. And so the efficiency of a product might be that it could be much more lightweight, or it could be a shell, or it could be a three-dimensional object that would be very difficult to make that works with sound attenuation or I think the possibilities are endless. A heavy piece of wood could be a light piece of wood. It can be perforated in ways that aren't simply drilled through, but in complex ways that are much more three-dimensional. So the kinds of products that could be produced, I think, are yet to be discovered, and that's going to be pretty amazing. I think if we think about the moment that a particular woodworking tool was created, like the CNC mill or the chisel, or what, it expanded the possibilities of making. And I think this is a moment where we're just going to expand the possibilities of making. So we could think about how traditional craft processes like wood restoration, for example, might play a role, but we can think about the future of wood products, and those are yet to be discovered. And I think those are going to be the most exciting discoveries that happen. And so that's like the one part of the efficiency. The other part of the efficiency is the fact that there is we're building from waste, essentially. We're building from the particles. And so part of that efficiency is that if you wanted to make a hole in the wood, you'd be removing all that wood and you would be left with a pile of wood dust, of sawdust, of shavings. We're starting from there. And so when we make something, we're not left with a pile of wood dust. We're only left with the product. And that residual waste can be recycled back into our system, and we can continue to make objects that way. And so that efficiency is, I think, a problem or a challenge that woodworkers face, right? At the end of the week or the end of the month, they might have these enormous bags of sawdust. And where do those go? What happens to those giant bags of sawdust? And that is a challenge for many woodworkers. Here's a process where we're beginning with that problem and we're solving that problem and turning them into viable products.
That's pretty exciting.
Yeah.
I love it. I love it. Well, I definitely want to keep up to date with your progress on this and share with our audience things that are made with Forust and how the process works in more detail. I'm sure that everybody listening to this wants to see pictures, and we'll be posting some online. We've already had one article about your process online, some samples, but we'll do some more. But and maybe we'll have you back on the podcast to talk about more details when things happen a little bit better. But this has been great, Ronald. I appreciate you coming on.
Well, thank you so much, Will. I appreciate it.
That's it for today. If you're looking for more of our podcasts, you can find all of them at woodworkingnetwork.com/podcasts and in popular podcast channels. Be sure to subscribe so you don't miss a single episode. Thanks again to today's sponsor, the Executive Briefing Conference. If you have a comment or topic you'd like us to explore, contact me at will.sampson@woodworkingnetwork.com. Thanks for listening.